Welcome to Daily Papers.
Today, we're diving into the world of cybersecurity and artificial intelligence. We hear a lot about AI being able to write code, find bugs, and maybe one day become an automated super hacker. But how close are we, really?
That's the exact question a new paper from researchers at Columbia, Berkeley, and other universities tries to answer. The paper is called The Next Challenge for Agentic Cybersecurity, and it looks at a very specific and very difficult skill, reverse engineering.
Okay, let's break that down. When developers write software, they write it in a human-readable language called source code. You can think of this like a detailed recipe for a cake. It has all the ingredients and all the steps.
But when you download an app or program, you don't get the recipe. You get the finished cake, a compiled block of ones and zeros called a binary. It's designed for a computer to understand, not a person.
And in cybersecurity, this is a huge deal. The most dangerous software, like malware, doesn't come with its recipe. Neither do a lot of proprietary systems that companies want to protect. If you want to understand what that software does, whether it's malicious or just has a security flaw, you have to work backwards from the finished cake.
That process is called reverse engineering. It's like tasting a cake and trying to figure out the exact recipe, down to the gram. It's a foundational skill for security analysts. And for AI to be truly useful in this field, it needs to be good at it.
So the challenge is, how do you test if an AI is a good reverse engineer? You can't just give it a pop quiz on some random software you found online.
Exactly. And this is the first major problem the paper tackles: ADM contamination. Large language models, the AIs we're talking about, have been trained on a huge chunk of the internet. If you give one a piece of open-source software to analyze, chances are it's already seen the source code, the recipe, during its training.
So it's not actually reverse engineering the cake. It's just remembering the recipe it already read. It's like asking a student to solve a math problem when they've already memorized the answer key. They're not showing you they can do the math, just that they have a good memory.
Precisely. The second problem is realism. A lot of existing tests use simple toy programs, but real-world software is massive, sometimes millions of lines of code, and high-value targets often have built-in defenses, layers of confusion called obfuscation, to make reverse engineering even harder.
It's like the cake recipe is not only secret, but the baker also added weird ingredients just to throw you off and jumbled up all the steps. Testing an AI on a simple cupcake recipe doesn't prove it can figure out a complex booby-trapped wedding cake.
So to solve both of these problems, contamination and realism, the researchers built something from the ground up. They call it SRE Bench. It's a brand new expert-level exam for AI reverse engineers.
And when they say from the ground up, they mean it. They spent over 5,000 expert hours creating 19 new complex programs from scratch. These are not toy programs. They average almost 17,000 lines of code each. They cover things you'd see in the real world, like network protocols, firmware, and even malware simulations.
Because this code is completely new and private, there's no way any AI could have seen it before. There's no answer key to memorize. And they also built a custom suite of those anti-analysis booby traps, 44 different techniques to make the AI's job as difficult as a human analyst's.
Wow, so they basically built the ultimate ungoogleable final exam for AI hackers. What happened when they put the AIs to the test?
They took 5 of the most advanced AI models available and set them loose on SRE Bench. And the results were fascinating. It turns out reverse engineering is still largely an unsolved problem for AI.
So the AIs didn't do so well?
Not really. The very best model they tested, which they call GPT 5.6-Sol in the paper, only managed to get a score of about 61%, and it only fully solved less than a third of the problems.
A 61% is barely a passing grade, and that was the best one?
That was the best one. The other 4 models performed much, much worse. One of them didn't fully solve a single one of the 262 test cases. The paper shows that even if an AI is fantastic at analyzing source code, the recipe, that skill does not transfer well to analyzing binaries, the finished cake.
What's interesting is how they failed. Did they struggle with the same things humans do?
That's another key insight. They struggle differently. For human analysts, certain programming tricks like compiler optimizations can make code really hard to read. The AIs barely noticed those.
Okay, so what did trip them up?
Something surprisingly simple, removing labels. In programming, you have names for functions and variables, which are called symbols. If you strip those out, the AI gets lost. This suggests that current AIs lean heavily on these text-based clues, these lexical anchors, to reason about the program. They're not quite thinking from the raw logic of the code in the same way a human expert can. The most telling part was when they ran a control experiment. They gave the AIs a version of a real-world public program, and the models solved it almost perfectly in minutes for just a couple of dollars of computing time.
Which proves their point entirely. When the AI recognizes something, the task is trivial. When it's faced with a truly unknown, complex problem, it struggles. This SRE bench really is measuring the right thing.
So, what's the big takeaway here? This paper shows us that while AI is advancing incredibly fast, there are still major frontiers to cross, especially in cybersecurity. The complex analytical skill of reverse engineering is one of them.
It's a reality check. We're not at the point of autonomous AI super hackers just yet. There's a huge gap to bridge before AI can handle the messy, protected, binary-only world that defines so much of cybersecurity.
But now, thanks to SRE Bench, we have a rigorous way to measure progress. It's a yardstick for a capability that's going to become more and more critical.
So, the race is on to build an AI that can finally ace this test and truly think like a digital detective.